This is class number 12 for Math 117, and we'll be looking at Jefferson's method and Adams' methods of apportionment today. And this goes with 4.3 and 4.4 in your textbook. All right, so our daily summary: in this lesson we study the apportionment methods of Jefferson and Adams. All right, so number 1, historical apportionment solution number 2, is Jefferson's method. So remember that in Hamilton's method we divided every state's population by the standard divisor, and then we rounded the result down. Up until now, things seem pretty fair. It's when we start handing out the surplus seats that some of the states might start to complain. So Jefferson's idea was to tweak the divisor so that when the quotas are rounded down, we have no surplus seats. To make this idea work, we need the quotas to be slightly bigger or slightly smaller. So we should make the divisor slightly bigger or slightly smaller. All right, so let's revisit Parador's Congress. This time we'll use Jefferson's method to apportion the seats. All right, so just as a reminder, we've got our total population over here on the right. And we've got the total number of seats that we are apportioning, 250. So the standard divisor, or SD for short, was found by taking the 12,500,000 and dividing it by 250. And that gives us 50,000 as our standard divisor. And that's 50,000 people per seat. All right, so our next step was we found, after finding that standard divisor, which is listed here in your table, let me highlight that. Remember, that's our first step. Our next step was to divide each of these numbers, each of the state's populations, by 50,000. And that's where these standard quotas came from. And that was the beginning of Hamilton's method as well. All right, so dividing each of these by 50,000. Just pencil in the rest of these. And divide by 50,000. And you can grab a calculator and double check these. Okay, so that brings us to our standard quotas, which is the exact amount of seats a state should get if you could cut the seats up into smaller pieces, or fractions of a piece. All right, our next step with Hamilton's method, and will also be the next step with Jefferson's method, is to round these down to the lower quota. And remember, that's the same as just cutting off the decimal. So for state A, that's going to go down to 32. State B is 138. C is 3. 41 for D. 13 for E. And 19 for F. And note, when you round these up, you get 246, which gives you 4 surplus seats. So Hamilton's method would go back in and look at these residuals, the residues, or remainders, and give those away, those 4 surplus seats away one at a time, based on who has the highest residue. All right, so Jefferson's, instead of doing that, Jefferson recognized that 4 of those states would be happy and the other 3 would not, or actually the other 2 would not, because we have 6 states. He decided that we would tweak the divisor instead. So if we use a divisor of 49,500 instead of the 50,000 above, we won't have any surplus. So if we take the state's population and divide it by 49,500, we get a modified quota of 33.25. All right, so again, we're taking the state's population, I'll write this out for A, and dividing it by this new divisor, a modified divisor. And that's giving us this new modified quota. All right, so if we do that for the rest of the states, state B's modified quota becomes 140.12. C is 3.11. D is 42.24. E is 13.83. And F is 19.95. And we don't need to add these up at this point. Right? Since they're rounded, or they've actually been truncated, we've just written the first 2 decimals down as we see them on our calculator. Not really concerned with what their total is. What we're more concerned with is whether or not, once they're rounded down, what those rounded down or modified lower quotas add up to. So for state A, because again, we're just cutting off that decimal, we round down to 33. B rounds down to 140. C goes to 3, 42 for D, 13 for E, and 19 for F. This we do want the total for. This row has a total of 250, and that's good news. That's what we wanted. We wanted to give out those 250 seats, and we wanted to do it in such a way that the surplus wasn't an issue. And so it was a nice way to solve that problem of some states being happy by receiving extra seats and other states not being so happy because they were left out. But Jefferson's method isn't perfect. In fact, there's a problem here that people noticed, all right, when they first started using Jefferson's method for apportionment. And the problem is with state B. And if you take a closer look at this column, you'll notice something a little funky happened. All right, so notice that they ended up receiving, so we'll put state B, received 140 seats, even though their standard quota was 138.72. And up until now, what we've seen is that with a standard quota of 138.72, sorry, I thought I had the highlighter on there, that a state should receive either 138 or 139 seats. But all of a sudden, now we've got a state getting 140. So it seems too big. Right? So they got 2 more than their lower quota. Right? They got something bigger than their upper quota. Right? So that was a problem that started to come up with Jefferson's method. All right, Jefferson's method, though, the question is, how do you do this method? Where did that 49,500 come from? Right? How did this number come up? All right, so Jefferson's method. Your first step is to calculate the standard divisor. Your next step is to calculate or find each state's standard quota and their lower quota, so you're chopping off the decimal. And then you sum those lower quotas, and if your sum is correct, you're done. And up to that point, looks like Hamilton's method. But typically that total's not correct, so you continue on. So this is where it changes. This is where Jefferson's method is different from Hamilton's. So if this sum is not correct, you move down to step 4. And you find a suitable modified divisor D. So you find one that works. And there's a flow chart on the next page we'll take a look at to help us narrow down what that modified divisor would be. Once you find a suitable divisor, you compute each state's modified quota, your state's population divided by this new divisor. And then you find the state's modified lower quota. So just like Hamilton's, you're chopping off the decimal. And then you find the sum of these modified lower quotas. If that sum, T for total, of the modified lower quotas is correct, you're done. If it's not correct, you go back to step 4. So there's a little bit of a loop built in here. You do these sets of steps over and over and over again until you get a total that you want, until you get the total number of seats that you're trying to apportion. Right, on the next page, the hard part of Jefferson's method is step 4. How do you find that modified divisor? Well, there's a flow chart here that can help you with it. All right, so you use D, you use that modified divisor to find your quotas. You round down to your lower quotas, so you're going to be getting your modified lower quotas here by chopping off those decimals. You add those modified lower quotas together and get your sum. We'll call that T for total. And then you check if T is the number of seats in Congress that you're trying to apportion. If it's yes, you're done. And you're all set. If it's not T, you got to go this way. And now you have some guides. If your total is too small, you try again by making your divisor smaller. So if your total's too small, you make your divisor smaller and start again. If your total's too big, then you make your divisor bigger and you start again. So you go back into that loop on the set of steps for Jefferson's method. But even more helpful is this last piece here. A very loose guide. So loose means it's not guaranteed to get you the right number, but it should get you in the right ballpark. A very loose guide for choosing how much to change your divisor by is to take 0.5% for each seat that you're off. All right, so from our previous example, so if you flip back to your previous page in the packet, remember that we had four surplus seats when we used the original divisor, the standard divisor. So we were off by 4 seats. So this is the number of seats that we're off. So we're going to take 0.5% times 4. So that's 0.005 times 4, because we've got to put it in decimal form to do our math. And that is equal to, if you grab a calculator, let's see, we've got 0.005 times 4 is 0.02. So that's how much we want to change our divisor by. So remember, our divisor was 50,000. So we want to take 50,000 times 0.02. And again, on your calculator, that's equal to 1,000 seats. Or there's not 1,000 seats, but 1,000 people per seat, because this is how much we're changing our divisor by. All right, so we know to change our divisor by 1,000, next step is, do we make it bigger or smaller? And that's where this part of the flowchart can help us. Remember that our total was too small. Right? We had 4 extras we still needed to give away. So this tells us to make our divisor smaller. So we would do 50,000 minus 1,000. And we would get 49,000 as a good place to start when trying to find a modified divisor. All right, so let's see those steps in action for number 4. Okay, so let's go through how we may have come up with that that modified divisor, 49,500, that we used above. And note that that divisor, that modified divisor I used before, isn't what we just found using our loose rule. Okay, so the next step, always start with the standard divisor and then adjust as needed. All right, so we've got our first row with the populations, nothing has changed. We got our next one with the standard quotas using our standard divisor, copied right from the previous page. Lower quotas, again copied from the previous page. Here was where we found that we were off by 4 seats. Okay, and since it was too small, T is 246, is too small. We know we have to make our divisor small by about 2%. Right, so that 2% was this calculation we did up here, that loose rule. Right, and again, by about 2%. That about is that loose part of the rule. All right, so if we're using this loose rule, then our next step would have been to try 49,000 as our divisor. So we would divide each state's population by 49,000, and we get these new set of modified quotas. Right? We would then lower those, so we'd calculate our modified lower quotas. So notice that the numbers in this row are just the whole number portions of the numbers above. And then we add them together. We want to find T. So we add them together, we get T is 252, which means we're off by 2 seats now, which is not the best news because we're not finding 250 as our total, but it is good news because we're not off by as much as we were before. We are 4 seats away with our standard divisor. Now we're within 2 seats with our first attempt at our modified divisor. Okay. And so if we're off by 2 seats, we can use that loose rule again. All right. So I'm going to come down here and we're going to try that. So if we take 0.05 or 0.005 rather times 2, we get 0.01. And then we want to do 0.01 times 50,000, which is equal to 500. And remember, we're too big, so we want to make our divisor bigger by that much. So we're going to take our previous divisor and add 500 to it. And we get 49,500. And that is the next one that gets tried. So notice in this next row, they're using a modified divisor of 49,500. They took each state's population and divided by that new divisor. And then they created these lower quotas based on those. So they're modified lower quotas. So again, this set of numbers in your last row of the table is just the whole number portion of the modified quotas. And when you go to add these up, your total is perfect. You're done. So you found a divisor that worked and avoided the problem associated with surplus seeds. Okay, so one other note I want to make here is that you can use that loose rule if you would like, but you can also do more trial and error if you prefer. But a strong recommendation is that you keep all of your tries. So whatever divisor you try, keep the results of that. Because let's say you had tried the 49,000 without using that loose rule. You just knew that you had to make your divisor smaller. So you dropped it down by 1,000, just kind of out of the blue. You have valid information here that can help you with your next step. You know that dropping the divisor down by 1,000 was too big a drop because you overcorrected. You went, instead of being below 250, you suddenly jumped up above 250. So you've kind of got two bookmarks here, or two bookends, I should say. You have something that gives you 246, which is too small. You have a divisor that gives you 252, which is too big. You've got to be somewhere in the middle. So then you go and you pick a divisor between 50,000 and 49,000. All right, and a natural middle number for that is the one halfway between them. You may have gotten to that modified divisor of 49,500, right, in 2 tries like we did here without even using that rule. All right, so keep all of your work because it can help you narrow down what to try next. All right, number 5. Jefferson's method is an example of a modified divisor method. 2 other modified divisor methods were proposed as alternatives to Jefferson's, one by John Quincy Adams and another by Daniel Webster. The only difference between the 3 is the rule used for rounding. As we've just seen, Jefferson's method rounds everything down. All right, so historical solution number 3 is Adams' method. And note that the first step is the same as Hamilton's and Jefferson's. You've got to find your standard divisor. But step 2 is a little bit different. You're going to find each state's standard quota, which is the same, but then you're going to use the upper quotas, and this is different. Hamilton's and Jefferson's use the lower quotas. Adams uses the upper quotas, which are what you get when you round up to the next whole number. So if you round your standard quota up to the next whole number, you get your upper quotas. After that, this set of steps looks a lot like Jefferson's. You're going to find the sum of your upper quotas. If your sum is correct, you're done. If it's not correct, then you find that suitable modified divisor. Again, suitable means it should work or get you closer to what you want, at least on your first step. And we'll have a flow chart to help us make those decisions as to how to modify the divisor. All right, once you get a modified divisor, D, you're going to compute each state's modified quota. Take the state's population and divide it by the modified divisor. And then you're going to find each state's modified upper quota. Find the sum of these modified upper quotas. If your sum, which we'll still call T for total, of the modified upper quotas is correct, you're done. If your sum's not correct, then you go back to step 4 and you start again. All right, so to find a suitable divisor, you need to make your quotas either slightly bigger or slightly smaller. So you should make the divisor either slightly bigger or slightly smaller. And again, here's a flow chart to help you with step 4. And it looks a lot like the previous one. Right? Use your modified divisor to find your modified quotas. But now you round up. Round your quotas up. So we'll call those your modified upper quotas. Okay. Previous step, you were finding your modified quotas. When you bump them up, you get your modified upper quotas. Add those modified upper quotas together and call your sum T. And then ask yourself, is T the number of seats in Congress? If the answer is yes, you're done. If the answer is no, you've got a little bit more work to do. So if it's no, you've got to ask yourself, is t too small or is t too big? If t is too small, make your divisor smaller and start again. If t is too big, make your divisor bigger and start again. And this set of boxes is actually the same as Jefferson's. We don't have to remember something a little different. It's actually the same thing. If your total's too small, you make your divisor smaller. If your total's too big, you make your divisor bigger and you start again. And another piece of good news here is that loose guide is the same. You're going to change your divisor roughly, right, by 0.5% for each seat that you're off by. All right, a mnemonic, number 7, to help you remember which methods are which. Right, Hamilton's, think of the first 3 letters there. There's always extra ham to give out. Jefferson's, think of that J, looks like a downward arrow. So it reminds you to round down. And then Adams is like an upward arrow. So it tells you to round up. So it helps you keep track of which one is which. And if you're curious about the history behind this, there's a link in Moodle with with a timeline. You'll have to scroll through the article a little bit to find your timeline. But you'll find some interesting information in there, including the fact that Adams' method actually never got used. They had discovered some problems with Jefferson's method and realized that Adams would suffer from those same flaws. And also of interest to you is Hamilton's method was actually the first one Congress had approved, but the president at that time, Washington, vetoed it, and it was the first veto in U.S. history. And so actually the first method that was used was Jefferson's. Hamilton's didn't get used until much later. All right, so the veto was in the 1790s, and Hamilton's method, I think, was adopted somewhere in the mid-1800s. Right, and you'll find in that timeline, if you read through it, that they actually kind of flipped back and forth between the various methods, and they tried to correct for some problems that they were finding by changing the number of seats to be apportioned. All right, so you read through that timeline, again, some interesting information in there. All right, on the next page is class activity number 12, so you get to try Adams' method here, and I want to make a note, all right. In numbers 2, 3, and 4, they all use this information. All right, so 2, and then on the next page, 3 and 4 are all using the same information. So the first part of the table is filled in for you. Second note, and I didn't point this out to you in your last class activity, but notice that I haven't filled in these rows with any kind of headings. That's up to you to do. And in fact, when you take test number 2, any rows you use to organize your work, I want you to label them. And so this takes into account that you may have an extra couple of rows if it takes you a little bit longer to find the divisor that works. So it gives you that flexibility to do that. Also, for instance, with Hamilton's method, some of you use a surplus row and some of you skip that row. So it again gives you a little bit more flexibility. You just need to make sure that you're labeling the rows that you do have numbers in. Okay, again, even more practice there for people that want some more practice with this, and it can certainly be done before a test is review. Okay, on the next page, you've got your reading and class preparation. So the reading, there's some guided questions here to help you make sense of the reading. And one more note, you've got some blank apportionment grids for homework 12 here. All right, so again, notice they're blank, so you can fill that in for whichever questions are asking you to do an apportionment. All right, that's it.